Hi guys, I'm Paul Kinlan. Welcome to our Chrome Apps special event. I think it's a special event. I'd like to introduce you to Renato.
Why is this special? I mean,
why is it special?
Just because we are both on the same place.
It is, right? So I'm from London.
And I'm from Brazil.
And we're here in Mountain View. We just came across all the way especially today.
And we are both developer advocates for the Chrome.
Yeah, actually, this is a Chrome Apps thing. We work on Chrome. We do lots of Chrome things. Today is actually kind of special because it's our first, I think, talk about using Node.js libraries. Node.js libraries inside Chrome applications. For you guys who don't know what Node.js is, basically in the past people have used it as mainly a server-based infrastructure, like a web server, SMTP servers, FTP. I'm going to say FMTP. I have no idea what that is. It's probably rude. But yeah, so a lot of people have been using Node.js, JavaScript on the server to build their applications out. It's asynchronous. It's all JavaScript. It's one single process, so it's pretty crazy to work with. Basically, the whole thing about Node.js is that everything that you develop and build is all meant to be asynchronous. So that you basically have, if you have any code that blocks, like making a database call, actually what should happen is it should sleep, and then the next time the next tick happens, maybe there's some data ready for you.
Which is quite similar as the JavaScript runtime runs on browser, right?
Yeah, that's the big thing that we're trying to do inside the browser is make every single API asynchronous, so that the whole user interface doesn't block when you scroll. You know, everyone knows what it's like if you put like a near infinite loop inside your code.
So Node.js is running JavaScript on the server, basically.
JavaScript on the server powered by V8. And what we're going to do today, at least, is show you how to run your Node.js-based applications, not all of them, because we don't have all the API support, through a tool called Browserify, which lets you run Node.js-based code inside, inside your applications or inside your web apps traditionally. But you'll notice from the actual project itself, it doesn't have access to, say, the network sockets APIs, which if you're doing like server-based work, and this is a kind of key thing for Chrome OS at least, if you're doing server-based work, you never have the ability to, inside the browser, open up a socket, for instance. And we can do that inside Chrome. So we're going to show you two applications, how to build them, and we're going to do that today.
Excellent.
We good?
Should
we go?
Yeah.
Should we jump in?
So just one question before you start diving into the code. So the point here is that Node.js is good for running on a server, right?
Yeah.
So why would we want to run it on the browser? And what's the difference between a Node.js code running on the server and running on a Chrome packaged app? Yeah.
So I think there's two bits to this, right? We're getting developers to build web applications, right? And we want developers to build web applications in JavaScript for the entirety of the stack, the client side and on the server side. And what we're trying to do, at least with getting Node.js modules to run inside the browser, is we're saying that, actually Node.js via the Npm package manager has got a huge ecosystem of libraries out there, work that's already been done by developers to get integration with FTP servers, FTP clients, HTTP web servers, all these types of things, the Connect, Connect and Express, these are middleware pieces of software that run web servers inside, inside the server. We should be able to take all that code and then also run that inside the client. You might ask why you want to run a server inside the client. If you look at Chrome OS, for instance, one of the things about Chrome OS is that there's always been this reliance on a remote server for your web applications. And we've always had packaged applications, which we're trying to say offline first is the way that you should go. You should build applications to work offline inside a packaged app.
But you can only run offline applications if all the data you need and all the process you need is on the client, right?
Yeah, exactly right. So what we're trying to do is say that, I think one of the big, I go to one of the big use cases, right? You look at the IDEs that are inside the browser, JavaScript, HTML-based IDEs for developing web applications. A lot of them come in inside the browser, but they still need a server to run all the run and debug the code, right? If you look at people like Cloud9 IDE, they basically have a Node.js background, like a background service essentially, where you can connect to it and you can debug your application inside the browser. We want to make sure that if you're building applications on the web today for your browser, then you should also be able to actually run and debug them inside your Chrome OS machine. Okay, Chrome OS is one use case. You bring that to Mac, Windows, and Linux, wherever Chrome is. That's a pretty compelling story. You have one piece of code that can run across all these different platforms, on the client, in the server, and all these types of things.
And would be another compelling use case for using the Node.js libraries on the browser, the distribution. Because currently, if I ask my mother to install Node.js and run an application on her non-Chrome OS machine, she would probably have some troubles with that.
Yeah.
So maybe if we the distribution model for the web and for the Chrome web packaged app is very compelling because it uses a store.
Yeah.
The Chrome Web Store.
Yeah, so all these apps they're obviously delivered through the Chrome Web Store at the moment, still will be. So the interesting thing is that you can build this IDE, or I'm not saying your mother's going to use an IDE. Is your mother a web developer?
I cannot tell you that. Maybe she works for Google. I don't know.
Yeah, maybe. Well, if you wanted to have these applications and make them available offline, you can install them from the web store. You don't have to install Node.js and all these types of things. You don't have to go and install that whole infrastructure. The browser is the runtime. The browser is this thing that can go off and run all your applications.
Excellent.
And that's what we want to try and enable. And I think that's where Chrome OS is going, is like these applications can live inside the browser. Or even outside the browser, but just written with the same technology stack all the way through.
That's great.
So I think it's pretty exciting. Should we jump to some code?
Yeah.
Yeah?
Fine. I love code.
Good? You love code? Really?
Yeah.
Nice. Cool. So we've got my Chrome screen in front of us. I think what we're going to do first is actually show two applications, just to kind of get the feel of what we're actually trying to build with these. The first is a thing called Markdown. So for any of you guys, it's a daisy, sorry. So for any of you guys who know Markdown, and we've seen some of these things in the past recently, where we're trying to standardize the Markdown editor. I basically built a Markdown application.
And Markdown editor, right?
A Markdown editor. It's 3 or 4 lines of code. So, okay, yeah, this is the interesting thing, right, is that we have NPM, which is a big package manager, a Node package manager for the web, or for your web services, which basically allows you to install any app, like kind of any piece of code that's been put into that repository into your web server application. Using Browserify, we can actually do that inside Chrome OS, or inside Chrome, inside your Chrome applications.
So you still use the same packages that are on NPM, but you use it on your web application.
Yeah. So there's a package called Markdown, which was Npm Install Markdown, which installed into my application, and then it's like 2 lines of code to actually interact with that module. So I'm going to show you roughly kind of what it looks like now. This is the code. So testing, hello world. It's just a simple, and I can't spell, I can't type either, which is kind of cool. But it's just a simple application, right? It does things where it can integrate with the file system, so I can then go and say I'm going to save this to my desktop. So testing.
So on the left,
GDL.
you type the Markdown syntax, and on the right, you get the HTML, the beautified.
Yeah, exactly. Yeah. So you get the rendered output on the right-hand side, and the actual raw input, the raw text on the side here. This is kind of cool. I kind of like this.
It looks like it's not 2 lines of code, 3 lines.
I do like
that.
I do tell a little bit of a fib. The thing is that we're trying to say it's 2 lines of, say 2 lines. Did I say 2 lines? About 10 lines of code of my code at least. So the Markdown editor has already been made and distributed via NPM. So the idea behind NPM at least is, and what we were saying before, is that there are thousands and thousands of modules and thousands of developer hours that have been spent building JavaScript libraries up to help you as a developer build applications that users will love. And one of those things is a Markdown module. So should we jump into the code? Let me see if I can just show you the code that we have here. This is what we're going to build today. So we go to source, index.js. I do have a lot of extra code. We're not going to go too much into this, and I do have a bug in some of my code as well at the moment. But essentially, this can interact with the Chrome file system and like with the user's file system and all that type of stuff. We're not going to go into that part today because we want to just talk about the node part of this application. So let's jump into the code. So I'll do via index.html, so you can actually see this is our kind of basic structure of our application. We have some images down the side. They're not too important for today. In fact, just to prove it, I'm going to delete 2 of them because we're not going to use them. And we have a text area where we're going to input our text, our Markdown code, our Markdown code, and then a HTML area on the right-hand side. I use normal CSS to style it up, nothing kind of special. I don't even use Flexbox. I was going to use Flexbox originally, but it didn't matter at all. So let's just jump into this. vsplit index.js. So index.js is the bit where we're going to put all of our logic, right, for our Markdown editor, which is this. Literally, it's going to be 10 lines of code. So I'm going to do the thing that everyone hates, but I'm going to do onload. So this is basically just saying the window onload event. I don't want to do an add event listener. It just adds too much extra cruft. But let's have a look. So md element equals document. Oops, sorry. Equals document. This is boilerplate code, and I can't type still. Markdown. There we are. HTML L equals document. I really can't type today. By ID.
This is the jet lag.
It's the jet lag. I woke up at 3 o'clock this morning, wide awake. I thought, you know what, I'm going to have to go to the gym. So I went to the gym. So this is the really interesting bit, right? This is, if you're a Node.js developer, you'll know this bit just straight away. We're going to use the require syntax Markdown. And so what this will do, this will actually pull in Markdown that we've actually pulled into our repository.
The require is like an import for other languages.
Yeah, it's basically like an import and include those types of things. We have to do, this is just a bit of, for brevity, is put that on the end because I just don't do another line of code. What you'll see now is if we try and run this, this application won't work because I actually haven't imported the Node package manager system into our Chrome application and I haven't run it through Browserify. So right now this won't work, but I'm just kind of showing you the code. So we'll go into this mdl, which is the markdown area dot on key press equals function. Here we go. Output equals markdown. I just realized I made a really weird noise. md.to HTML, that's the one. mdl.value. So what we're doing here, it's relatively simple. We're taking the data from the text area, passing it through the markdown system. And
so on every key press, you run it through the renderer.
Yeah,
renderer.
It's pretty inefficient.
That's all right.
I think. But yeah, it's pretty cool. So, and I'm doing something we probably shouldn't do as well. Inner HTML equals output. And that's it. That's all we need.
Is this inner HTML equals output a big problem for a Chrome packaged app, as it is for a web page?
It's not as big a problem. We have content security policy, and by default, content security policy inside Chrome applications.
Because this is one of the biggest source of exploits, right?
Yeah.
On web pages.
Yeah.
Okay.
It is. Yes, it is. Nicely set up. But yeah, this is the point, right? We have this thing called content security policy, which basically says, well, I know all the resources that my application can access. So I don't allow dynamic script loading and injection from third-party sources. I won't allow images to be loaded in from other sources as well, and likewise with cookies and all that type of stuff. Yeah. And if we can disable those things and eval and
so it's basically impossible to put a script tag on inner HTML.
Yeah. So
because it doesn't evolve.
Yeah, with Markdown you can kind of, in some versions of flavors of Markdown, at least you can inject HTML code yourself, which the normal plain HTML code will be fine. But if it finds a script tag, it won't let you do it. You can't run script tags in line. Eval is disabled as well, so we can't do those types of things. So it's not great from a kind of the way that we encourage developers to build applications that interact with the DOM and kind of make new DOM elements, but it's relatively safe. So let's break out of this. The thing I really want to do is I'll show you actually I will show you how to build and bring in your Node modules. So the basic thing we do, npm install, which if you've installed Node inside your development environment, npm basically comes pre-installed. And we have the ability, it's like kind of Git where it's got a special set of command lines. Install is the ability to install modules into your local application working directory. So let's install Markdown. Goes off, gets it, and if this all works, this is cool. So if I do a brief look at this, we have this directory called Node modules. Oops, a daisy, sorry. with a Markdown module inside there.
Excellent.
This is packaged up inside my application when I deploy it, so I know I've got all the dependencies that I need. If Markdown required other dependencies, for other kind of Node modules, it'd bring them in and kind of import them in.
And now you were talking about Node.js specifically. There is nothing related to the Chrome package app yet, right?
Yeah, this isn't specific at all to Chrome packaged apps. This is just a very, we want to use a basic Node module. How do we actually use a Node module inside Chrome? We're not quite there just yet. We have to do this thing called Browserify. Yep, it's a really nice project. Basically, the reason why this all works and the reason we can do this today is because an external developer has basically made it so that you can run Node modules in the web. And we're taking advantage of all this kind of functionality to say, well, we can do this for our Chrome applications now. So Browserify is the project. It's on github.com. But basically what we do is we import the Markdown module, which is fine. And we then output it to a file called bundle.js. So if we look, this is not going to make too much sense, but if we look at bundle.js, it's basically including all of the code that's needed to run basic Node.js applications inside the browser and also Chrome applications.
So that's the secret step.
Yeah, it does all the secret step. It's I've done none of this work. It's all been done by the community at large, and we're just taking advantage of that for your Chrome applications. But we'll jump out. It's imported Markdown. It's in there, and if we jump into Chrome, load a unpacked extension. Projects, GDL, Markdown, styles, we've added it in, and this should, if we view the code, this is our code. Yep, this is our proper project. Testing, hello.
That's awesome.
World. Yeah, so I've from like my user code, I've only done a couple of lines of basic code.
10. Okay.
10 lines of code. A lot of it is Bootstrap, of like bringing in elements and all this type of stuff. But we literally have been able to build this application out using other third-party modules, quickly using the Node npm package manager. Yeah, and it's pretty cool.
Awesome.
It's pretty nice.
It's really cool.
So do we have any questions from?
We have some, but
we can deal with that actually. Can we debug? I think that's the biggest one, right? Is like, can we debug a Node application? So the thing to notice about this is Node is built on the back of V8. Chrome's JavaScript engine is built on the back of V8. There's a lot of things inside Node which are purely written in C, essentially. They're like wrappers, hard wrappers to the V8 engine. So what's actually happening now is this is really just an emulation of Node and its libraries on top of inside Chrome. It's not a full Node.js system inside Chrome. So that is actually, it might have some kind of negative benefits, like negative aspects to this, in the sense that, if some modules have been kind of written in C and are kind of specially optimized for Node on the server environment, we're not necessarily going to get that kind of performance out of it because, the buffer object, for instance, in Node.js, we have to manage that ourselves, right? We have to manage that inside JavaScript. Inside Node, that's actually managed by a basically native code. So the interesting thing is, it has a negative, which is potentially performance. I don't think it's going to be that much of a problem, though. The benefit, though, and to answer this question, is that we can actually debug these things a lot better inside the Chrome DevTools. The reason why we can debug these things inside Chrome DevTools is, well, you'll see it now, is it's just a HTML and JavaScript web-based application. So if we go here, reload page. So if we reload the page, we should still have our breakpoint still set. If we break into this, you'll see it breaks into this bundle.js, which is the compiled code from the Browserify project. So it's pretty cool, right? I mean, we can do a whole load of stuff. Doesn't make much sense for me to show too much else about this, but everything's JavaScript, everything's imported inside the browser, which means that you can debug your applications. It doesn't mean that you can go and debug your Node-based application on the server. You still have to go through the existing methods that you use that way.
So basically, what you're doing there on the debug part, you're debugging the bundle.js, and the bundle.js is like it will be like the Node runtime quoted. So does the bundle.js has some what type of limitations aside from performance that you already mentioned?
Yeah. So some of the limitations it has at the moment, it's only got the basic APIs of Node.js stubbed out, which for the majority of modules is fine, right? It's absolutely fine. But if you want to do network sockets, for instance, or serial port access, those types of things, they don't exist on the web. So the engineers behind that Browserify project have not implemented them. But that doesn't stop us from doing it, because the really cool thing is that Chrome has got inside this packaged app, this new apps platform module, at least anyway, it's got access to a whole load of kind of hardware-based APIs. So we can talk to serial ports, network sockets, so we can do TCP and UDP. What else can we do? USB, Bluetooth.
Bluetooth on some platforms. We have window access. We have a different file system.
So we got file system API as well. And the FS module as well inside Node is pretty cool. But what this allows us to do in quite a few cases, as long as it's an asynchronous API inside Node.js, is that we can have a really good kind of go at fleshing out the actual implementation. So we can provide the Chrome implementation over, say, the network socket API that maps directly to the Chrome's socket API.
Like a wrapper?
Yeah, it's just basically a wrapper. And it's on GitHub today. I've already got one for the net module, which is what I'm going to show you now. So it's a nice lead in there, thank you. So this is our next application. It's not going to look like much. If you've ever done anything with XML HTTP request, you'll say, well, I can just use XML HTTP request. But this is all about just doing a demo. So news.ycombinator.org. I really should do my blog instead. Port 80, because this is a bug in my code. And all it does is it makes a request out from my Chrome packaged application, and actually does, rather than does XML HTTP request, it uses the net module inside Chrome OS, well, not inside Chrome OS, Node.js, so that we can actually make our request out using that module. In this case, it's just
it does a raw TCP.
It does a raw TCP connection and then writes the HTTP request out to the socket, and then the web server will respond, and we just display the data. So as you can see, I mean, it's just telling you all the header information and a whole load of other stuff there. It's pretty cool. I really want to show you guys the code because I really like this code. Most of it's taken from the Node.js documentation, just to kind of see how easily it works. Let me just remove this there. So as you can see here, we have the net module, require net. This doesn't come with Browserify, but I've made the wrapper. I've made the wrapper for Chrome, so we'll see that in a second when we get in the code. We basically pass the URL. This is actually a really nice API. Someone in the Node.js community, I think it actually might be default inside Node actually. They wrote a proper URL object, which means that we don't have this. We don't have this in the browser, right? We
can't deal with schema, ports,
to deal with schema, ports, parsing, query strings, path. The closest that we get to it is the location object, right? And we can't construct a brand new location object just inside the browser. It's a real pain. But now it's in Node. You just do. Here's the code here. If we just zoom in a bit more. Oh, I won't zoom in that much. URL.parse, and it parses the value, the string that we put in, and returns a URL object. It's beautiful. It's really nice, and that's all thanks to Node and the fact that we can run this inside Chrome via Browserify. So, should we just jump in? I mean, I've shown you the code anyway, but we'll probably just jump in to show how easy it is to do this thing.
Is it like 3 lines of code?
No, this is a little bit more. It's 4 lines of code now. Web requester. So if we view index.html, you'll see that I've just got everything already made for us. It's too much effort to go and do all the HTML live. So let's anyway vsplit. I can't spell vsplit at all today. Index.js. Edit anyway. That's fine. Right. Cool. And in this one, I prepared all the boilerplate code ahead of time.
Okay.
So let's just jump into my code. I actually have written it out here. So it's var net equals require net. This is using the same Node.js import system to import the net module. Var URL equals require URL. And then var sys equals require sys. And that's basically all of the modules that we need for our application. Now, the really cool thing about this is that we're going to basically pass the host. I love this. It sounds stupid. It does sound stupid, but I just love this module because I can do so much with it. I'm just going to take some values that I'm going to use for later on. Port, and this is why I love it, right? Pass int host.port or port 80. So the bug that had my code originally, it didn't have this or 80 in, essentially. So if you didn't put a port in, it just assumed that there was no port. Host hostname. Cool. And that's kind of all we need to pass it out. And if you've ever done anything like this in JavaScript, trying to parse out URL fragments and syntax for someone, like if someone's giving you a URL, you'll know how hard it is. So it's just nice the fact that we can actually bring this into our applications. This is actually, if you use Browserify just normally, this is available to every web application. So if you need a URL object parser, that's the one to use. So client. So if you're a Node.js developer, you'll know this already. Net.create connection with my options. Set some encoding. Actually, I put this in just to be a nice citizen. I actually haven't stubbed out the code for this. So, right, this is the meat of the code now. Client connect. Oh, can't spell function. There we are.
We have some YouTube commenters telling that you misspelled the require, the C's require.
Oh,
I love this
nice,
stuff.
nice real-time feedback.
Thank you.
I still can't spell it. There we are. Thank you very much. Yeah, so this is done live. Only practiced lots of times, as you can't tell. I'm sorry. Host.path. So what this is going to look like a bit of voodoo magic. Well, not necessarily really voodoo magic, but you'll see what I'm doing in a second. So this is because we as kind of web developers, we know and understand the structure of the code and how to make a HTTP request. The thing about the Node.js stuff, or this application, is that we're using the raw socket API. It doesn't know how to make a HTTP request, so we're actually formulating the request that we're going to make out to the remote service. So once we have a connection and we know that we've successfully connected to the service, we're going to build out this request host. Host.host. I could have refactored this a little bit more, I suppose. /n/n. Boom. Client.write. And I'm going to explain a lot more about this right now. So what we've done here is we've created a connection to the URL that we specified in the text box. I couldn't think of the word then to save my life. We've basically passed the URL out. We made the connection to the service. Once we know that we've connected, there's an on event, essentially. It's an event emitter inside Node.js. So it's the same style eventing logic that you have, which is different to normal websites.
This is very common for Node developers.
This is very.
They look at the code and
exactly. We formulate the request. It's just a GET request. It doesn't do much else. It takes the path, tells it it's of HTTP 1.1 protocol, and then gives it the host name, because that's what we need. And then it writes it out to the socket. So what we've done in this part now is that we've taken this code and we've basically said, open the connection and send it to send the data to the web server. The web server will send us data back. However, we can't do anything with it just yet because we've no way to handle it. So let's have a quick go at that. So client.on. So this is another event. On, I can't spell. Data. Oh, wow. Data. And we're not going to do too much with this. Result.inner text. It can be multiple requests. So let's do that. Data.toString. And there we go. I think we're all closed off.
So what you're doing with the response from the server is just setting it on the...
Yeah, we're just setting it on the div just to show you what's happening. So the interesting thing is this, again, will not work. Because we've not imported the module. So I actually have the URL. I've not published it live into npm just yet because there's a whole load of things I want to get sorted out. But it is on GitHub. So npm install git github.com/Paul Kinlan /net chromify .git. Installed. It's actually installed it from my local system because I actually had it on previously. Demo fail. But let's have a look. Let's see if we can load. Oh, what am I doing? I apologize. Load it in. Web request all. Testing. .org. It doesn't have an index.html. Oh, we got an error. Let's have a look what it is. Well, should we show off the debugging support?
Leave the bug session.
Sorry?
Leave the bug session.
Do you want me to leave it?
Live the bug session. There is one question on YouTube. Monteslu is asking, where is window.require? Because you call require method on the full namespace.
So let me show you actually. This is the so where is the window.require? This is interesting, right? So this is exactly what Browserify does for us. Oh, you know why it didn't work?
Why?
I'll tell you why it didn't work.
You didn't execute
So let's actually answer that question. So Browserify -r net chromify net. So map the net chromify module to the net namespace. Sys and also include URL and output bundle.js. So if we look at I apologize again. Bundle.js. This is actually where it's defined. So
all right. So what Browserify did there is imported out the node modules that you specified, and generated the bundle with all this.
Yeah. So basically, if we do search for net, then it's basically brought net into this bundle object. So bundle.js is a collection of all of our node modules. It's a collection of all the core functionality that's needed via.
And does it also look for dependencies inside those modules? For example, if net depends on another module, it does look for those dependencies.
Yeah,
right?
so I've actually got a bug fix out as well for this inside Browserify. But essentially, if you look at the Markdown project that we had before, they had some sub-modules. So if you go require another JS file, Browserify will, when you do the Browserify process, it will go and parse out all the modules it needs to load into this one JavaScript file.
Awesome.
And to the same extent as well, you have to pre-require like all the core libraries in yourself. But it'll spit out an error that you can't find one of the modules you'll need. But the really interesting thing just generally is if you do an npm install, you only really have to do the top level module for it to go off and go, well, I know all the node modules I need are
like if net required like TCP module, I don't even know if there is one. If you do npm install net, the TCP module would also
I mean it's all part of it.
Cool.
And net in our case here is our own module. But if we required any extra modules, if we broke it up a little bit to make the code a bit more maintainable, it'll bring all them in. So yeah, it can do that. So I actually want to see if I fix this. Wow. News.mycombinator.org. I'll just do port 80 as well, just in case I didn't fix the bug. No, it didn't work. So yeah, this is live. We had a demo fail today.
I trust you.
Yeah,
the code is working.
Thank you very much.
That's really awesome. So what you did there, you created a simple code that uses the net module, but the net module is not Browserify. It doesn't come with Browserify, right? So you wrote a wrapper around the Chrome packaged app sockets APIs.
Yep.
and converting those APIs to the net module,
Yeah.
the same syntax as net module.
Yeah, exactly.
So you can use exactly the same code that uses net module, you can use on your Chrome.
Yeah, exactly. Basically, it's a complete mapper to the Node APIs.
Pretty cool.
So which is kind of cool. Is like if we want to access serial ports and all those types of things, it's pretty cool.
So we can have developers creating those wrappers for every API that is not supported by Browserify, right?
Yeah, exactly. Yeah.
Awesome.
So the really interesting thing as well is that the net module itself doesn't come with a server. So I'll rephrase it. It comes with client connections. You make the connection, but you can also create a TCP server with it as well. And I think from our talk the other 2 or 3 weeks ago, where we talked about Chrome actually has listen and accept methods now, so you can actually have Chrome running as a web server or any type of server that you want. I'm doing a little bit more work. It's not an amazing amount, but what's going to happen is basically you're going to be able to run a server, your node-based server in theory, inside your Chrome application. So if we have the complete mapping between the net namespace, then it'd be so cool if we can get, you're building applications with Express or any of the kind of the Node kind of middleware modules for building web servers. You can actually run your web server and all your code inside your app. And it's like when you're thinking about these native, like these newer kind of native-like applications where you have all the logic on the server and well, you're offline. What happens? Well, you can have the similar type of logic on the client, and then your pure UI client itself still makes the same types of requests out to the server. It doesn't really have to know it's offline. It just says, well, I'm going to make these requests, and they get delegated back to our application and then to the main web server.
That's really cool. And we have a huge community of Node.js developers, right? So we have a huge amount of projects using Node.js. And if those projects can run on the client side, and if it makes sense for those projects to run on client side, it's a huge thing for users and for developers that have a user base much bigger than the...
It just it kickstarts your whole development process. You can build these native type of applications really using code that developers have already made. And if you don't want to use Node, then we still have our raw kind of low-level socket APIs, for instance, for networking, like the raw APIs that you might need. But a lot of developers don't like dealing with raw APIs. But we have the ability to go deep into the raw API or higher level with the Node modules at least.
That's really cool. We are running out of time. Maybe we can jump into
Should we jump into some questions?
Yeah. Okay, so the first question from Luis of Phoenix. How does NPM fit in? This question was made before the session began, but even though I think you can give a quick answer.
Yeah. So I mean, I hope it's been kind of relatively clear about how NPM fits in. Is that it's just part of your kind of development lifecycle, right? So you'll have your application that you're developing, say, on your Macbox or Linux or Windows, and you'll do npm install. It'll install the modules locally. They don't have to be locally installed because essentially what happens is Browserify inspects all the Node modules that you've installed into your application space, essentially, and then says, well, that's cool, they're there, but we're going to make this big bundle file, and then you'll install that inside the browser.
So the user of your web application, that uses Browserify, doesn't need to have Node or npm installed. It's
just you as a developer, and if you're developing Node-based applications, and you'll be using npm anyway. It's the same type of process, apart from this Browserify step, which you basically have to use to convert your kind of code, like the code, and like import all the module syntax and all type of stuff in.
That's cool. Okay,
it fits in.
The next question: what are the sandboxing restrictions?
Yeah. So I suppose there's a couple of different types of answers that we can deal with in this. Sandboxing comes in a couple of different senses. There's the content security policy, which basically sandboxes the amount, like the things that you can inject into a page. So you can't include external resources unless you explicitly in your manifest allow them. But if you're making kind of requests out to the services, then if you're using the Node-based Net API for sandboxing, then it's all permission-based inside Chrome. So let me just jump into, if we can, jump back into some code for the web requester. The manifest basically has this line at the bottom, which I tried to highlight, socket TCP connect.
You have the same restrictions as standard JavaScript code running on a Chrome package app, right?
Yeah.
It's exactly the same. You don't run native code you don't run the native part of Node.js. It's just JavaScript.
You don't run the native part of Node.js, and if we, for instance, use the net module, for instance, that breaks out to the Chrome.socket API,
So
which
you need permission.
is permission-based. So, when you actually want to deal with these lower-level APIs and these kind of more advanced functionality than you get with a normal application, then this is actually done through kind of a permission-based system. So we have the exact same sandboxing model as a normal website, a normal web page. Web pages can't request data automatically from another web page, like injector, they just can't go cross-process. So it's the same type of sandboxing models.
Okay. Next question from Chills. What build is this available in?
Yeah. So this should work in, I think we're a beta, aren't we? We're in beta for the beta channel, at least of Chrome.
23?
23.
Yeah.
Yeah, so the best place to test, this is all still kind of in development and experimental at the moment, but it's getting to the point where we want to get it live. The main thing to notice is that I'd say work on dev channel and Canary, because there are still kind of changes to some of the APIs going on, and whilst the network socket API hasn't changed in a long time, and I'm pretty sure it won't, we've just got to make sure it's not unstable. It's not unstable just yet. So I would work on the dev channel for now. Work with Browserify as well.
Especially if you use the TCP list, and TCP list is only on Canary.
Yeah, so TCP listen actually is only on Canary, and it's only on the experimental flag as well, I think, isn't it?
Yeah.
So if you want to do server-based work, we'd love you to kind of get you guys to go out and demo it and kind of work on it and give us a lot of feedback about that. But yeah.
Where we can find more docs on Package Labs.
So developer.chrome.com/apps. That includes all of our documentation. It actually doesn't have this web. I can't believe someone actually noticed this unless they looked at the code.
That's
really
actually
cool.
pretty cool. That's really cool.
So
this is the one.
WebKit app region. And I know we're running. WebKit app region is it's a piece of CSS syntax that allows you to define, because you'll notice in this application that we have here, we don't actually have a title bar, right? And if you don't have a title bar, how do you drag the application around? Well, the WebKit app region is the piece of CSS syntax that you use to actually define what's draggable. So I've made the left bar here draggable, and if we inspect element,
actually the WebKit app region specifies what is not draggable.
Yes,
right.
And then you specify in here the drag. So basically, you've specified the drag area. So you can say none or draggable. We don't actually have that documentation. We need to get some documentation for that because it's very Chrome app specific.
Okay, so we need to make a different HTTP package to use the Chrome TCP listener?
So I was under the impression that the HTTP package was mainly about making XML HTTP requests, like style requests out, which is kind of supported with XML HTTP request anyway inside the Browserify project. If you want to go and make a special Chrome-only version that uses the sockets, then that's perfectly possible, but I think the code's already there. For the actual TCP listener, that's included in the net project. So in theory, if there was a server component to the HTTP project and it included the net module, then they should just work in theory and get pulled in. I will say now that the code inside the net module for creating server-based accept and listen modules, it doesn't work yet, and I'm going to get it live soon. I've got to run through all the unit tests.
But you don't need a different HTTP package. I mean, you need a wrapper around the.
Well, HTTP. I mean, there is already a HTTP package, and the way that Browserify works, if you have HTTP like -Browserify, it'll use that module, so you can make your own Browserify package to replace what comes by default.
Yeah. So your application that uses the HTTP package doesn't need to change if you provide the same.
If you provide the same base level API, you should be fine.
Okay. And here we come to the last question on moderator. Is there a registry to compare builds in Node packages versus what has been done, like your net package?
We could start a list. So could we start a list somewhere? So the interesting thing is that we definitely don't want to fork the Browserify project. But the Browserify project basically says these modules need work to do. But like we said in the previous question, is if you make the module itself net-Browserify or HTTP-Browserify, and then you import that into your project and via Npm install that module, then Browserify will delegate to that piece of functionality, so you can override all those different areas with your own functionality. So we do need a lot more. I've only worked on Net because it was the sexiest one to work on, because I could build a web server inside the browser.
But it doesn't include robots. Why is the sexist?
It doesn't include the robots.
Yeah, it should include robots to be the sexist.
So funny you should say this. There's a whole competition now for accessing Mindstorms, Arduinos, what else is there? The AR drones and all those types of things, where people are doing it inside Node.js, and we've written our own stuff to access the Mindstorm before in Chrome, and we've also written.
We definitely should do that.
Yeah, I mean it's already been done in Node. So the thing that should happen is we should just provide the base API wrapper.
That's true.
And then all these applications that are written for Node should work automatically.
Controlling a robot using a web application.
Yeah, we should do it. I mean, we just need to get those extra bits filled in. And if anyone wants to help me, email me paulkinlan@google.com, and we'll get started.
Okay, so and let me check if there's
any more YouTube comments.
Questions.
Why Vim? I like Vim. Renato's done some really cool stuff with Sublime, which we'll show it in a future episode. So I might move to that at some point. So
maybe I can do the same for VI, because I also love VI.
Yes, we kind of be good. A special Vim package.
Yeah.
Or bundle, whatever they call.
So we are pretty much done.
I think we're pretty much done. Thanks, guys, for listening. I'm Paul Kinlan.
I'm Renato Mangini. Thanks for coming and listening.
We'll see you next week.